John, this is
Yes.
Novak. Hi.
Hi, Mark.
So sorry, my video doesn't work today. I want to talk to you about something we're doing in the Trustworthy Workload Identity SIG, and how it relates to the certifier framework.
Sure.
Would you mind if I set up some time with you?
No, absolutely. Go right ahead.
How do I find you for the
Do you have
video?
my email?
Um, well, let's assume I don't.
Okay. And now everybody will know it's John Manfredi, just like my name is spelled,
Yeah,
at hotmail.com.
donmanfratelli@hotmail.com. All right.
Okay,
Thank
so
you.
just let me
I'll
know.
reach
And if
out.
worst comes to worst, you can always do the poor man's get a hold of me via LinkedIn.
LinkedIn. Yeah. Okay. Sounds good.
But it's
Now you know
better to
it's
send me
coming.
mail. I only occasionally looked at LinkedIn.
All right, of course. Thank you.
Thank you.
Mhm.
All right, we're at 10 after, so why don't we get started? I can share the slide deck. I'm happy to run through this operational stuff unless there's somebody else on the call who would like to do it. Like Ijal, I don't know if you want to jump in and cover until Kevin can join.
Holidays last week and wasn't in our sync.
I only caught part of that. I don't know if that's my internet.
Yeah, I was saying I would rather you go ahead and do the first few slides as I wasn't in our most recent sync due to
Okay,
holidays. Yep, thank you.
okay, no problem. I'll start it off and hopefully we'll get Kevin on here shortly. All right, folks, welcome to the August 20th meeting of the CCC Technical Advisory Council. As a reminder, this meeting is recorded and is available after on YouTube. So we are an inclusive community. We strive to be welcome and opening and respectful of everyone's opinions, even if we don't agree with them. So this is just a reminder that we strive for inclusivity and kindness. This is also a quick reminder of the Linux Foundation's antitrust policy notice. This essentially means you don't talk about things that aren't already public. If you have any questions about exactly what that entails, please let me know, and I'd be happy to get you in touch with our legal team, who is much more knowledgeable about this than I am. So the agenda has had a slight change since Kevin sent out the bullet points yesterday. The MITRE paper has actually been moved to the September meeting. There's some last minute scheduling stuff that came up with those folks, but otherwise everything else is the same. I don't see any change that I'm aware of in the list of voting representatives, but if there are any changes, just reach out to myself or Ben and we can update the list. I don't think there's anything voting coming up today, so we don't need to go through the roll call for quorum. At this point, we'll open it up if there's any new community members. It's your first or newish time joining and you haven't introduced yourself before and would like to introduce yourself to the community. This is your opportunity. Let us know who you are and why you have joined.
Hey everyone, I've seen a lot of the new faces, so I'll introduce myself. My name is Kevin Jones. I'm the founder of OneClaw. That's the number one claw.xyz. We use Google Confidential Compute for doing execution intents, so essentially keeping secrets away from AI agents. Yeah, great to meet all y'all. Thanks so much.
Thanks, Kevin.
How do I put myself? Hi, can you hear me? Yes.
Yes.
Oh, cool. Hi, I'm Edward. I'm working at a startup back in the United Kingdom, so it's the afternoon for me. Specialize in confidential RPC, remote procedure calls. Basically, I'm working on the serialization, transport, attestation agnostic RPC for enclaves and non-enclaves. This includes synchronous and asynchronous I/O, one-way function calls, and it's meant to be targeting multiple languages. Initial languages, C++, soon followed by Rust, and it's going to be basically made public soon. But you can see I'll put on, there's an older version of what I have on my GitHub, so you're welcome to look at that. But it's if anybody is old enough, they might remember a thing called Carmen Corber from the 90s, and basically this is revitalizing that, making it modern and secure. That's me.
Thanks. Welcome, Edward. Any other new folks?
Hey, Michelle, this is Raghu. I'm not able to get my camera working, but I am not a new member, but I'm a guest today. So I'm just going to do a quick intro.
Sure.
I'm from Intel and I work in confidential computing as well. And I think I put the first draft of the agentic AI paper, and I was asked to come join this call. Not sure if it's Q&A or what, but yeah, I look forward to the conversation.
Great. Thanks for joining. Yeah, there's a lot of good discussion going on around that. So excited to get to that point in the agenda. Any other new folks?
I have a question, Michelle.
Sure.
So I used to attend these meetings when I think Dan from Intel was chairing it. And but now it sounds like the management team changes.
So Dan Middleton is still the chair, but
Yeah.
the CCC has been doing kind of a rotating chair for the TAC meetings for the last, I don't know, 6 months to a year. Ijal, you might know better when y'all started doing that.
Yeah, actually, Dan was indeed with Intel, and then he's no more working with Intel now. He's with NVIDIA, but he's continued this year as well as the chair for the TAC committee. And I am the co-chair for this year. Last year it was Yash.
So Dan is still chair of the tech?
He is. He just changed affiliations. He changed employers. He's now with NVIDIA, yes.
Got it, got it. And Michelle is a new chair for
No, I am the program manager for the Linux Foundation supporting CCC.
yeah.
But for these meetings, for the TAC meetings, there's like two different two different meanings of chair, right? There's chair of the TAC, and then there's like chairing a meeting. And for these
Ah,
meetings, we've been rotating the person
got
who's
it.
chairing this meeting, but
Got
but Dan remains the TAC chair.
it. Okay, thank you very much. I
Yeah.
got it.
Yeah,
It's
he's
clear
just
there.
on vacation this week, so that's why he
Yeah,
hasn't joined.
yeah. I know he changed the jobs too because this is what he said last time. Yes.
Mhm. Yeah.
And
Okay.
hey, John, nice to see you again.
Good to see you.
Yeah,
Well, almost see you.
yeah, very soon. Yes, very next, yes.
Great. Any other new folks? Okay, we'll keep trucking along. So this was the agenda from last month's meeting. All those meeting minutes and links to the deck and the notes and everything are available on GitHub, and the recording is on YouTube if you want to go back and take a look. Announcements. This was something Kevin had added in. There's an upcoming Linux Plumbers Conference in October. It sounds like there's going to be some CCC folks at, and we just wanted to call out if there's any additional upcoming events for the fall event season that folks are planning on attending and just maybe want to do some informal meetups. We don't have any top of mind since they just had the CC Summit that we would do like a formal gathering at. This is more just a call if folks are going to be attending anything specific and want to get together. Hey, Mark.
Yeah, Nora's attending is probably going to be virtual, but in September we expect to have an interim meeting of the RATS working group. And the TWI SIG is going to be presenting a draft there. So, and it's related, of course, to confidential computing. So again, to participate in TWI SIG meetings.
Okay, great. Thanks for letting us know about that. Anything else folks are going to be doing? Okay, well, if something comes up, feel free to drop it in the TAC Slack channel or to the mailing list. I think people are always interested in hearing what's going on in the world of confidential computing. And this is the new business. We already went over the agenda. So with that, I'm going to stop sharing and let John jump into his presentation for the Certifier Framework project.
Okay, I'm going to jump. Okay, can you see my screen?
Yes, we see your desktop right now if you want to go
It's
into
okay.
Perfect.
There's nothing interesting on my desktop. Don't worry about it.
Now that looks perfect.
Okay. So I'm going to talk about the certifier framework. We've been part of the CCC for a long time, and then back last summer we got an intern from the CCC. So thank you. I'll tell you what's happening first. Overview, and then go to a little more details. So first of all, as you probably all know, there's organizational change. VMware got bought by Broadcom. They put the stuff in open source, but the people who worked on it in Broadcom have either gone to other companies or have stopped working on this. I've maintained it, and recently we've gotten new participants. A company I started called Datica. Paul England is probably the most prominent contributor. You'll hear a little bit more about that later. And the new breaking news is we very recently, like 2 weeks ago, got a grant from NSF to do some work in this area, and we'll be collaborating with a bunch of government agencies, but also USC and University of Virginia, possibly some others. So that will be very helpful. So I will review the goals of the original architecture, tell you what's gotten. Actually, there have been a fair number of additions and improvements, despite the fact that we had relatively few developers. And I'll tell you just a little bit about aspirations and gaps that we're hoping to fill, and maybe a tiny, tiny bit about research we're planning to do. So, okay, to remind you, the certifier frameworks an open community project. The idea was to vastly reduce the time to build applications and now VMs. It supports SGX and SMP. Those are the main ones. We would like to, there's a sort of very early version of CCA support that Samsung helped do called Islet, and a very early Berkeley thing, Keystone. There's also a simulated enclave so you can develop on any machine that doesn't have any hardware or anything. It provides a very simple API for applications, but we believe it's complete support for edge cases. We'd like to build a support library so that the most demanding security applications can use it. But if uh, you're not prepared to write your software quite as safely as you can, or you need to move quickly, we'd like to do as much as we can to help you earlier rather than later and ease the path into a fully secure application. There are no dependencies on central authorities in ours. You can run it yourself if you want. There's no dependence on third-party trusted anythings, including the guys who sign certificates. It's a very easy infrastructure to manage, and it's scalable. So, for example, you can add applications without going through hell. A very simple certification. It's policy-based, and in fact, when you're admitted into what we call a security domain, there's actually a proof based on the policy for why you were admitted. Okay, I guess that's all I'll say there. There are two parts, and actually now a third part has been added that I'll tell you about. There's in the especially like the SGX days, the focus was an application, and now VM-wide tools, and I'll talk about that. And you linked in a certifier library. We call that the client that made it easy to write these programs. And I meant easy, like, if you had a good, well-written program, like literally I would try to do it in front of your eyes in under a half hour to turn it into a CC program. And then a certifier service that admits you into a security domain. So, and the library is linked in, and the service is just a separated service written in Go. We support AMD, SEV, SGX. We just added one of the new things is TPM. We did that for two reasons I'll explain. We would like to add CCS in the newer version of RISC-V. And one sort of noteworthy thing, if you have a VM level protection, we can also provide app level protection and something we call the application enclave if you trust the separation inside an operating system. So a use might be, if you're Google and you're part of the organization doesn't trust anyone else, they don't want to run anybody else's machine, but you sort of semi-trust each other. You might have a VM and have several of your applications in that. Okay, service runs anywhere. You can run it on the same machine you run the application in the cloud, anywhere you want. It's completely scalable. Okay, so the progress to the last meeting, we added a new library. I'm very interested in the person who talked about our PC support to provide granular resource protection. The certifier framework certifies things based on the program, but you can, if you're doing data sharing or agentic, blah, 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 you probably want much more granular protection based on additional authentication keys you hold. So we added that as a prototype. We added TPM support for two reasons. Pure TPM, does not provide, the King's English version of confidential computing because there's no encrypted memory. But given our sort of pragmatic outlook, we like to do as much as we can. Don't forget the whole idea of the certifier is if you start out on one platform and move to the other, you just change a declaration. So we sort of hope people who just have TPMs move to a better environment at some point. But the more important point is that we have people in the government and other places trying to use it that use cloud providers. And many cloud providers do not attest or do not provide attestations to the full application or VM or anything like that. What they typically do is attest to lower level booting stuff and then defer to a virtual TPM in the VM. So with the TPM support, we can provide equivalent. I mean, it really is encrypted memory and all that stuff, confidential computing protection without rewriting programs using a virtual TPM. There's some new utilities. As I said, before we focused on applications, we still do that. But in the case of VMs, they're actually like shell level programs you can run to do a lot of the management of the system rather than writing programs. We support multiple trust domain. A guy I worked with at Microsoft, who many of you might know, Paul England, he and I were one of the original developers of the TPM stuff. I'm sorry. He and I and another person started a company to work on this, the company that got the grant. There was an initial Java support that the intern done. We're still trying to fix other stuff in that. And there have been a lot of bug fixes since you last heard. We would like to, again, the whole gestalt here is we'd like to support all platforms. And you write a program or you use a VM, whatever, whichever. And if you move to another platform, it should just work with change in declaration. So we'd like to support CCA, possibly Raspberry Pi with a change in the firmware, iOS, and many of these are not pure, again, King's English confidential computing platforms. Amazon asked about Nitro. We could support that. And TDX, of course, we can support. We've also done Hopper. But before we got the grant, we were a little bit at a disadvantage. It was hard for us to get access to hardware to test it, but that will change now. We're looking for grants to do interesting apps and appliances so that you just kind of pull it off the shelf and use it. That would kind of be nice. And we're sort of involved in research partnerships, mostly with the federal government, and maybe looking for others. There's some possible things we could do. I'm expecting someday somebody will come to me and say, you have to do it all in Rust. The service is actually in Go, so maybe they won't complain about that. We'd like to introduce automatic container specification, measurement, and deployment. And that's at all levels, from the VMM to the VM to the possibly the Kubernetes container, or whatever container you like. We're thinking about integrating automated formal methods using AI, because you got to do AI. And we're very kind of interested in side channel protection. Side channel protection is the one sort of gap in some of the King's English, the real, honest to God, confidential computing. And it mostly has to do with an adversarial VMM. So that's something that we'd like to see fixed in a practical way. Just to review the concepts, there's the concept of a security domain. When your program is a trusted program and is evaluated, the certifier service admits it to a security domain by certifying a public key, which you can then use for a mutually authenticated TLS channel. Certification refers to the process of looking at whatever measurement evidence is presented and saying, oh, and whatever else, the hardware, all that, and saying, oh, yes, I trust this environment for this activity. We don't trust policy is never hard coded. There's a policy language based on one of Butler Lampson's languages. And there really are very few basic concepts. One is the basic object of the trust manager that manages the trust relationships, a secure authenticated channel, which I just mentioned, so you can open up a mutually authenticated and encrypted and integrity protected all that channel between two members of a security domain. So it basically extends the envelope of protection around two things. And then a policy store, this simple policy store that stores sensitive information sort of automatically. Of course, you could also do it yourself, but as I said, we'd like, for most applications, you really just don't do anything except the standard thing. Just to review, this is basically what you do to make an application, a confidential computing application. You declare what crypto you're using. Oh, actually, one other thing I mentioned, whenever the hardware gets quantum resistant crypto, we'll add that. There's a trust manager object where you declare what enclave you're supporting, like this one is SEV, the name of the store I just mentioned, and there are two purposes in using confidential computing. One is the typical one, authentication. You have a program and you want to prove its identity to somebody else via an attestation and say you should trust me because I'm this program. But you can also have recursive confidential computing things. So the other purpose is attestation. So a VM can attest using the hardware, but then a program inside the VM, if you want, can use the VM as a sort of a parent to attest to the program rather than the whole VM. Basically a four-step thing. You just initialize the enclave. Everything is rooted in a policy key that's embedded in the program, whether virtually or in real life. That's the thing that everybody else in your security domain trusts, though only the actions signed ultimately by that policy key get used. You init the algorithms, make up your keys, get certified, and you're off and running. And then the only thing typically you do after that is open up a secure authenticated channel. And there are two roles, the standard TLS-like roles. You could be a client or a server. If you're serving up RPIs, of course, you'd be a server, and it's likely, there's some interface to that. We actually use protobufs as our serialization. So you use that, and there you go. That's it. I guess I won't do this. I've done this before. I guess not very much of a change in code, but we've had people ask for this. A single program or VM can now be in multiple trust domains, multiple security domains. So it wasn't a big deal, but there you are. The program is actually measured. Everything is pretty visible. We have a standard application we write for each supported program. In fact, mostly it's copy and paste. And in that standard application, there's a client and a server, and they both get certified. And in the end, the client sends the server a thing over a secure channel. It says, "Hi from your secret server." That long number is the name. It's the measurement of the program. That's the unforgeable measurement, and the server replies, "So hi from your secret server." By the way, one thing introduced by the TPM is in the past, there's been a single measurement. TPMs, they have these PCRs. So now you can specify mechanisms for the measurement as well. It's not that big a deal, but just so you know. The things you might want to add, we've added, except for a Byzantine agreement. We haven't done anything on that. Maybe something we're up to, we'll do that. This is a sales pitch. It's simple for most applications. The interface is abstract isolation, measurement, sealing, and unsealing, and test. So really, you have to know very little about the underlying technology to use it properly. I confess we're not purists, so if there is a platform that is not really confidential computing, for example, it doesn't have encrypted memory, we'll support it, and of course encourage people to go to the better platforms. We would very much like to support more clients. We would like to see it not just on servers, but on clients. So we've done experiments with mobile devices, things like Google phones and Apple phones, and I think I mentioned Raspberry Pis. Paul invented this TPM-like mechanism called DICE in IoT devices. We may support that as well. And I was at Bell Labs when in that Unix group, and so that's always kind of my standard for behavior. And I'd like to say probably it's not completely true, but it's an aspiration that using it is almost as simple as the hello world that they distribute. Certifier service is policy driven. This is an example of a proof of why something was admitted to a security domain. It's scalable. I did something like this. It wasn't confidential computing at Google, and I often got beat up about scalability. So I'm very sensitive to that. When I built this, it was built to the final version, or it was informed by the final version thing I built, which was scalable by Google standards, which is pretty scalable. And that's it. We're still looking. We're like I said, we just got funding. We're doing well on incorporating applications. We have a bunch of interesting applications people want to do. We're still looking for a little bit of support for things like systems programmers. We'd like to support a lot of platforms. Maybe some of the agencies will fund that. But when I did SEV SNP, it took me 2 weeks to connect it to the certifier. It was a nice, simple interface, and a really great guy I had at VMware did a very simple simulator for it, and the kind of low-level interface, which was also pretty simple. But adding a new platform doesn't take very long, provided you have the system support. So, for example, TDX and CCA, and even things like Apple and the Google phone would be easy to add if I had a little more support. Right now, they're really basically just the two of us, and we're pretty focused on what we're now funded to do. The funding actually has to do with health applications. We're also looking at scientific applications and analytical applications. So that's it. It's still quite active. It's too bad, the Broadcom guys went away, but they did put it into open source, so thank them for that. So at this point, I think I'll answer any questions people have. And thanks to the Linux Foundation. Go team. I should say the company is supporting this. So work we do to improve the certifier framework is going into the certifier framework under the same Apache license. There are some things we work with customers that don't go into the thing because they're not part of the certifier. They're more specific applications. But we would really like as much as possible to have this be a nice portable platform that anybody can use. It helps us build applications and VMs. And even if you don't, use one of our applications or any of that stuff, we'd like you to benefit from the work we've done. So there you go. Are there any questions? Maybe the other Kevin's here.
Hi, can you hear me?
Yes.
Hi, interested. So can you dynamically link to kind of trusted domains together dynamically at runtime, or is it statically done, or how is that done?
I'm not quite sure what you statically mean dynamically. Yes, you can get added to a domain dynamically. By that I mean you have a program which whatever this new domain guy says, oh yeah, now I trust that program. Yeah, you issue a rule to the certifier saying this thing's a-okay for my security domain, and it's that. Now, when you said dynamically link, I think of code, adding code, and you actually we don't support it as part of the framework. You can do that as well. That would be based on a signature for the thing you want to add. But as you originally framed the question, we support it now. You just say, go ahead, add this guy, add this program.
Cool. And is this bound to a particular network protocol, or can it work over any transport?
No, it works on any transport. For the secure channel I mentioned, the default thing is to use TLS with mutual auth, with client auth.
Okay.
But if you decided to use Joe Blow's mutual auth client thing, you could add that. I mean, but we typically try to use standards when possible. First of all, because people probably use that already when they're talking to their programs. So
No, is they work for multiple different transports, such as TCP, IPC, SPSC.
yeah, and they're not TLS, but you can't run a TLS session over them?
You can do kind of some form of key exchange, that sort of thing between
Yeah,
these.
so if you can run TLS, it's automatically supported. But again, if you maybe that's an addition. If you have an addition like support this transport, we do have some government customers that have some wacky stuff sometimes that they want us to support a different transport. I mean, it's not conceptually hard. It's just you want to make sure the key exchange is the right, it isn't screwed up and all that. Yeah.
Okay, that makes sense. Thank you.
Anybody else? If you know anybody who wants to participate, it's still an open source project, especially for the systems work, or if you're interested in us supporting other platforms. We'd like to support platforms. As I said, typically, but for the low-level systems work, if there is any, it doesn't take very long to add a new platform, which is good because there's only one of me. Anybody else? Going once.
Could you have, for instance, a daisy chain of trusted zones, and zone A passes a credential to zone B that can pass into zone C, type of thing?
Well, for the granular protection, yes. For the program protection, you should think of the certifier service as being a one-to-one map to a security domain.
Yeah.
So you're either trusted within a security domain, and then maybe there's subtrust. You can do this, but not this, or you're not. Period.
That makes sense.
And again, I guess maybe one other hidden philosophy is keep it simple. If the minute it gets complicated, I mean, I'm a security guy. I hate complex stuff because everybody messes up, including by way of illustration and not limitation, me. So, so yes,
Yeah.
at the security domain level, you're either in or you're out. Now, you can be in multiple security domains, the same program or the same VM or all that. That's okay.
Thank you.
Okay, any other questions for John?
And thank you again for rescheduling, Michelle. Sorry, I had to go to DC last time.
Oh, good. Thanks for being able to join and provide the update.
Again, anybody who wants to participate or knows anybody who wants to participate or has relatives who want to participate, you should just let me know, especially as regards platform support. And I don't know what these other collaborators we have, if they'll call for any further stuff, collaboration. So good luck.
All right, let's see here. Back over to the agenda. All right, so we have some work in progress. I think this will go back to, this is the link, the AI papers where we want to start. So let's see here.
Are you?
Raghuram, you have been working on this.
Yeah, are you going to share it, Michelle, or you want me to share it?
Can you guys? Oh, I'm sharing something. Wrong screen. Hold on.
Sorry, I should have mentioned that it is on GitHub. It's on my last slide. Somebody asked me a question. I'm typing a response in there, but it's on GitHub. You can see all this stuff. And in fact, as soon as I update the presentation, that will be in GitHub too.
One second.
I can share it if you can't find it.
Why don't you share? I found the link, but if you want to, if you're the one going through it, then it probably makes more sense for you to share it anyways.
Yeah. Is it, you guys can see it now?
Yeah, perfect.
Okay. All right. So this was a paper that I drafted probably about a couple of weeks ago. And there have been some comments from different folks. By the way, thank you for those. Some of them have been disposition. Some of them, I have some comments and I'm getting some back and forth with the comment creators. So my intent is to disposition the comments as soon as I can. I still have a day job, so it's a little bit challenging going back and forth, but I will commit to getting it done as soon as I can. And not sure what the next steps are, but at least I will address as many of the comments and close them before this forum decides what the next step for publications and things like that are. Okay. I think the big chunk of the comments, I don't know if Manu Fontaine is there on the call.
Hey, Raghu. Yes, I'm here.
Hey, Manu. I think maybe it's worth for you and I to have a one-on-one conversation, maybe later this week, or maybe not later this week, but maybe next week, so I can understand some of your comments, which sound interesting, but I'm not getting the full context of them. So
Yeah, we can. I was actually, I thought we could discuss it here too, because I think it's important for, the whole community here. The main thing that we realized is that confidential computing enables, first I made the change to the title, and I'm requesting that we call it agentic computing instead of agentic AI, so it goes beyond AI. Because as we know, to have reliable, dependable AI, we're going to need deterministic software agents that are, cryptographically verifiable. So there's both probabilistic, models that should be isolated in confidential compute. That's confidential AI. And then there's, we see a need for deterministic software agents that are themselves isolated in confidential compute, because those software agents will need to be able to do things like credential management on behalf of an AI agent, and then be able to identify themselves, authenticate, and do access control in a very granular way. And so one of the capabilities that we think the CCC in general is under emphasizing or promoting is the ability for an AI, sorry, not an AI, a deterministic software agent, a software actor running in a confidential compute environment to generate its own cryptographic keys with no dependency on external key management systems. And that is a capability that enables now the isolation of a software agent from all other dependencies, because now that agent can actually encrypt its own knowledge and its own credentials and its own identity related information in a way that excludes literally everybody else, not just the operator, the physical operator of the infrastructure, the cloud service provider, but also the owner, the organization that deploys that software agent. The reason why this is important is because now that agent can actually act on behalf of an entity that is neither the CSP nor the organization that deploys the software. It can act on my behalf. For instance, as a human, I can have a human agent that can run in an environment, and if that agent, my personal deterministic, software actor, can actually create credentials on my behalf. So it's as if I had my own personal, completely isolated software actor that can now hold my wallet, identify and authenticate myself, encrypt my own information in ways that doesn't leak to anything and anyone. And that we believe is critical for agentic workflows, because that's what enables then the chaining of those agents, where an agent can authenticate itself to another agent with guarantees that the keys that are being used for authentication and or information encryption are not leaked anywhere else. They only exist inside that agent after being verified, of course, because all this should be attested and verified. So that's the main push to the changes. I didn't want to disrupt the flow of the documents. I wanted to make the comments in there to bring up that critical, I think what we believe is a critical agentic capability enabled by confidential computing. But I agree with you, and I understand that it comes a little bit out of left field. So more than happy to spend more time with you, but I wanted to give that explanation here.
I don't disagree with anything you said, Manu, but at least my understanding was this paper was supposed to be kind of scoped for agentic AI. And I'm okay if the TAC agrees that, hey, it should have a broader scope and make it agentic computing. But then now the threat models are going to be a little more enhanced, and the workflows would be a lot more complex. And we're just increasing the scope and the complexity of the paper. Or do we consider it as, hey, this paper is very targeted for agentic AI, and but there is a need for a broader scoped paper like you were calling agentic computing, and then that paper addresses the entirety of what you were talking about.
Yeah, but
that's a choice. That's the choice that the TAC has to make at some point.
Right, and I would then push back a little bit on that, because the issue of of agency is really an issue of trust boundary and an accountability, knowing who has access to what, when, and if so. I think what the paper is describing now is more like confidential AI as opposed to agentic AI, because unless if the organization that deploys those agents has access, if there's basically external dependencies, and the trust boundary of the agent in fact includes all the other external system to the agent itself, then you really don't have any assurance that the agent is actually acting on behalf of a specific entity. You have a whole bunch of other actors and things in the trust boundary of the agent itself. So this feels to me like more what you describe, more confidential AI, as opposed to agentic AI and or agentic
that
computing.
wasn't the intent. The whole idea was it talks about agentic, the implications of agent loop and the implications of the different types of injection attacks. That's not really confidential AI per se, right? Confidential AI could be just classic confidential AI, right? Basic inferencing, or training or fine tuning kind of thing. This specifically goes into some of the use cases and specifically the threat models related to agentic. So I necessarily don't agree that the paper is confidential AI centric. Maybe there are some aspects of it that are very narrowly scoped for the agentic one that maybe you are alluding to saying, hey, maybe this requires a little more broader coverage to meet the spirit of agentic computing, but I don't know. Maybe you need to provide some specific examples for me on why you think it is a confidential AI versus an agentic paper.
It really is the trust boundary, and it should be defined very clearly then in the paper where, can you trace back, the actions of the agent, and do you provide assurance that the accountability is bounded and the trust boundary is clearly defined for that software actor. And very quickly, you see that the minute you have dependencies on external things outside of the trust boundary, you've essentially degraded that trust boundary. You've expanded it, and so the agency itself is now diluted. And I think that I see that Ophir has his hand up.
Yeah,
Sorry, I
thank
can't
you.
see the screen now, so go ahead, please.
I want to relate to your first point, Manu, and I think that this is the important discussion that we should have. You were talking about we can measure and trust deterministic agents, and the real challenge here is with those autonomous agents that are asking something from the LLM, and the LLM actually directs them on the commands that they will run with different systems, different MCP servers, and so on. And that is, I think, the thing that we should discuss here, because at the moment, Raghu, when I was reading this paper, it was like an agent is like any other piece of software, and like we say, you need to run it in an enclave, you need attestation. I think that it's too simplistic, and it could create a false trust in that case. I'll try to explain. When it is an autonomous agent that randomly, I'll call it for the sake of our discussion here, gets the commands to run from the LLM based on a prompt, we don't really know what it will run. And so attesting it is attesting, it's like attesting a Kubernetes node rather than attesting and measuring specific pods in that Kubernetes node. You don't know what will run there. And you are testing it and you're saying, yes, I trust it. But that code is totally not deterministic. So I think that
that's a good point. Okay. Okay. What I would contend is with confidential computing and agentic AI, what can be asserted are the deterministic pieces. Okay. I can assert that this is the right agent. It has the right measurements. The measurements are verified. The policy binding that it has, that is a attested policy. But when an agent goes into an agentic loop and LLM gives it a set of dynamic things it has to do, that is now outside the scope of what confidential computing can measure and attest and verify. Now it is very dynamic. This is and non-deterministic.
exactly.
That LLM gives as a subtask to my agent. The agent is going to go try to generate some code and write some even execute that code. And that part of it is not measurable by confidential compute.
Exactly. So I think that it's not reflected in the document. I read the document, and if I was someone that does not know what confidential computing gives and what it doesn't give, I could get to the wrong conclusion that, oh, I have a way to create that trust. So I think that should be reflected here.
Okay. And Manu, you're the net of your statements at the beginning. Is it aligned with what? I'm sorry, who was the person who was speaking?
Ophir.
Yeah. So is it very aligned to what he was saying?
Well, I think Ophir and I are thinking alike that there is, if we write a paper like this if the CCC is expressing a perspective on agentic AI and agentic computing, I think we should put our best foot forward and really explain why it's fundamentally necessary I personally strongly believe that we're not going to have any, how to say that, dependable AI and without hardware isolation and containment of AI. And of course, provenance, integrity, confidentiality of prompt and all context information, all of those things. So I think from that perspective, I think Ophir and I are aligned. The point that I'm trying to make is, I think, more fundamental. And Ophir did say, I think we do need a serious discussion around the fact that, for instance, agentic identity today. I mean, everything I read about agentic identity is completely missing the point that if the agent is not the only entity, the only software actor that has access to its own authentication keys, then you don't have, accountable agentic identity. You have something that's proxied by whoever is operating the domain, and you have domain-centric identity, and you have insiders, and you have, the conventional attack surface of non-confidential compute that comes in. The opportunity here is to define software actors that only exist in hardware-enforced trust boundaries that can generate their own credentials and their own encryption keys to protect their own and isolate their own knowledge. Knowledge isolation, I think, is the piece that we should realize that we have, that confidential computing brings on, in addition to execution isolation. So that really is the main argument, or the main point that I'm trying to make here, that this paper, if it is to be representative of the differentiation of confidential compute compared to everything else that exists out there, it really has to encapsulate not just execution isolation, but knowledge isolation, because that's what will enable software actors to have their own independent existence, identity, credentials, reputation. You can build, cryptographic primitives from that hardware enforced isolation.
Sorry, I understand knowledge isolation. I think that's an interesting dimension that has to be added. Okay. But the challenge for that one is the following, right? Agents have short-term memory, long-term memory. Some of this knowledge goes into that long-term memory, I would imagine, in either a raw form or in summarized form, right? Now, you're talking about isolating that with keys that are generated inside confidential compute by the agent, and then that way the knowledge goes in an encrypted form into some persistent store. The whole discussion about keys, who manages them, where are they managed, where are they persisted, all those aspects have to be discussed as well. So suddenly we are increasing the complexity of what we want to say in a paper. Like, I'm okay to do that, but we just have to be aware that some of those aspects have to be addressed as well if we get into knowledge isolation.
I think that Kevin raised his hand, and it's worth giving him the chance to join.
Okay, sorry, I am not able to see this.
Yeah. So we can be your moderators.
Yeah, please go ahead. Yeah.
Kevin. Oh. I have a feeling that Kevin has an issue. Kevin, we cannot hear you if you're speaking. I see that you unmuted yourself, but you're still.
Can you hear me now?
Yes.
Can you hear me now? Okay,
Yes.
Sorry about that. My AirPods. Thanks so much. No, this is great. I think it's a really good first kind of approach to this confidential compute for agents. This is exactly the kind of stuff that I'm working on at OneClaw is and I think there's some value to thinking about confidential compute in the architecture story of how these agents are actually communicating. So it's not as black and white as just hey, you just run your agent in confidential compute and that's enough. It's more okay, well, you actually need multiple TEs, you need multiple policy kind of verification, hardware verification. It's almost more like the story of how we need to build these agentic systems in this kind of trusted execution environment. But I think it's amazing, and I personally would love to help with this. I mean, I mentioned in the comments, if anyone wants to share that with me, I would love to add some comments and contribute if possible. Just let me know.
Oh, absolutely. Yes. Would strongly love it. Okay.
Raghu, could
And
you please put the link of the document in the chat?
yes, I will. Yeah.
And I hope that I'm not throwing you into the water, Mark Novak. But last week when you presented the work of the workload identity, you started talking about defining in a higher level what does it mean really agentic AI for us to discuss.
Yes. And in fact, so this is how I would frame it. First of all, I want to understand, and I've never been convinced that agent is more than just software. Like to me, agents are rechristened bots, and they have certain complications because they use LLMs. Okay. But then once you understand that what is actually different in kind, not in degree, then you can actually say, okay, that tells you what problems you're going to solve. And then you have a definition of done. We're done when the following things are addressed. And until we know the difference, we don't know why existing solutions don't work. And I just haven't seen that articulated very well. I mean, so your credentials are a little shorter lived. So you need to figure out how to do delegation. But I mean, okay, but that's the kind of stuff you deal with workloads, right? So then the other, and this is more of an architectural trap that I see people fall into. They start commingling credential acquisition with credential use. And the moment you start doing that, things get very, very complex, very, very fast for no good reason. So, you see whimsy drafts that all of a sudden start inserting evidence into, Windows identity, workload identity tokens. And this is the kind of stuff that, you can not only start solving the wrong problem, but you can start solving it in the wrong way. So these are the discussions I welcome very much.
Mark, this is great. How do you see a paper like this evolve to address those kind of infrastructural things? Would it make sense to add it as additional sections in a paper like this, or you foresee that to be, hey, here is an identity centric extensions to a paper like this?
Yeah. So there is a paper that I think does a fantastic job of framing the problem, and that's the paper out of CSA, and I think it has some Microsoft imprimatur on it. And the good thing I will say about it is that it really does a great job framing the problem. And you read it and you're like, oh, I understand now which problems I think I need to solve. Now, that same paper proposes that we solve it by almost literally boiling the ocean. Like there are decentralized identities and there is a new lookup service. There's like a lot, right? And then you look at it and saying maybe the way you framed out the problem was to justify this big solution you got. So, but I think whatever you're doing and by the way, that paper doesn't even get into the confidential computing side of it, which is ultimately just protecting keys and protecting data in use and that sort of thing, right? And incorporating attestation into credential acquisition is really all confidential computing can help with. So I would suggest starting by first reading that prior art. I think that again, the paper does an excellent job framing the problem out. And then, maybe you agree with it, and then maybe there's a simpler way of solving that. Or maybe you disagree with it, and then, reference the paper and say, well, these are the differences. But I would not like us to start the problem anew because the problem of agentic identity exists, right?
Yeah.
People recognize it.
No disagreement there, right?
Confidential computing only does so much to help.
Somewhere down in the paper, I think I remember writing a reference to, there's a section where I talk about where does confidential compute help in the agentic stack, and there's a section on partial coverage where you see, identity and trust, where confidential compute can help in generating the identity material and doing all of that, but you still need a proper PKI infrastructure on top of it. And again, I don't fully remember the CSA paper. I might have read it once, but let me take a look and see if there is anything that
If you want to give me a minute, I'll go online, find it, and provide a link. It's not terribly hard to find. But as I said, starting anew would be a big waste of time.
Yeah, totally agree. Yes, and if there is actually prior art on this,
Yeah.
either we use it, or if we differ from it, we indicate where we differ from it. Yeah, makes sense.
So the paper, literally, you can type CSA paper on agentic identity. And let me stick this in the chat so everyone can see this. So again, read it with a grain of salt, because yes, it does a fantastic job framing it out, but also it frames it out in such a way that the huge solution that it proposes fixes everything. Right? So the two parts are not independent. And then let's be humble and understand, so for confidential computing, whatever solution the industry comes up with for agentic identity, which it will, I mean, all it can do is aid with assurance that the code or the model that's being run or the prompts or whatever, is really the thing that it is, and associate key release with that. Like, we cannot do much more than that.
And I mean, are you saying it in the context of that identity paper? I'm sorry, I'm a little bit.
Well, I'm just saying the industry will be solving identity problems with or without confidential computing, right? So let's recognize that, and then look at it from the standpoint of how can we make these efforts better, right? Because somebody will deploy some agentic identity solution somewhere. And then you'll come along and say, you will do better if you stick your agents inside a trust execution environment. And this is why. And here how we can help you. And if at this point in time you say, oh, and you have to completely rewire your entire identity management architecture, they will tell you to go stuff it. Right?
Yeah,
so
I don't think that is the direction we will go. Okay. For the simple reason, confidential computing and its use for agentic is an enabling capability. It does not modify the control plane functions that are there significantly. So things like creating agent identities and authentication and all of the and access control, those kind of functions, they would still happen. All I think we can probably espouse is, hey, these things, if the identities are created in confidential compute, there is certain amount of integrity protection that you're going to get. If the attestations happen in a way that are bound by confidential compute, there is integrity there. I think those are the claims that we can make, but I don't believe anything in confidential compute is going to fundamentally change the way identity processes work today.
It won't it will if we're careful. The point is you have to keep that goal in mind. You cannot be too disruptive to your hosting environment.
Okay, so your suggestion is there is something more to be said about agentic identity in the context of confidential compute that needs to be said here.
Well, yeah, I also provided this feedback to Whimsy. Whimsy just adopted an agentic identity draft. And if you read it carefully, that slippery slope of injecting credential acquisition into a problem that they're solving, which is credential usage. Once you start there, that's going to be a problem. And they don't deal with confidential computing head on today. So yeah, my recommendation is to first understand what problem we're solving, and then understand which parts of it we can help with, and then do that. Manu, you had your hand up.
Thanks, Mark. Yeah, Raghu, you were so firm in saying you don't believe that it can change things. Actually, we are currently operating a global identity provider capability that is 100% built inside confidential compute, inside Intel SGX, by the way, that completely eliminates dependencies on conventional identity management attack surfaces. There is no central directory, no Active Directory, LDAP, or any of that, and all identity information and credential management is all recursively and hierarchically managed inside the software agents that protect and encrypt their own knowledge and on their own information. So I do, there is a path. We proved it and we're operating it now. And so that's what I'm saying, is that we should really think about how confidential computing actually changes the capabilities, the toolkit, the toolbox that we have to rethink, fundamental infrastructure pieces like identity, like decentralized credential management, and decentralized encryption in a way that is globally and recursively verified. You said at some point that we still have dependencies on large PKI systems and things like that. If you have a software actor that can, generate its own keys and protect and isolate its own knowledge, then the only thing that it needs to be able to persist is its own keys, right? The initial keys that it generates to then generate other keys. Well, guess what? You don't, to persist that initial key, all you need is another software actor that has the same properties, the same capabilities. And now you can stitch together, an architecture that actually recursively encrypts and protects information in a way that you don't have external dependencies. So there is a path. There is a, I'm not, and Mark and I, we argue about this a lot. We obviously need to meet the world where it currently is. We're not going to boil the ocean and just, throw everything out. But we shouldn't also, as the CCC, we should not underestimate the new toolbox that we've created, which is execution isolation, and then generation of full entropy credentials inside trust boundaries that can be secured and verified in hardware. This is no small feat.
What Manu advocates for is actually very wise, right? In the sense that going to the nirvana is desirable. Everyone wants that, right? But it may be a step too far. So if you provide an intermediate step that meets the customer where they are and a reasonable path to do better, then that's absolutely a path to adoption. If you insist that the intermediate step be taken out because nirvana is where everyone's got to be, you limit your upgrade potential, and that's not good for technology, right? So
and that's the point I was going to respond to, Manu, to you is, at least the lens from this, where this paper has been written, is there are many control plane functions already there today. And those control plane functions, when they work in confidential compute, what changes do they need to go through, still maintaining this existing kind of workflows that enterprises are used to today? So that is that intermediate step that I think Mark was talking about. That's the lens with which this paper has been written. Okay, this paper hasn't looked at, hey, I have this new isolation mechanism, and can I completely re-architect my control plane functions? That's not the intent of this paper. Okay, and I agree with Mark on that one. If we go with that as the architectural model, I think it's a bridge too far for many enterprises to get into right away.
I want to suggest a way to move forward, because this is a very good discussion, and this is what we suggested that we'll have last meeting 2 weeks ago. I think that there are things that we should look into and address them in this document. Many of the activities today around the autonomous agents need to be addressed here, but I want to suggest that instead of running in circles today, Mark shared with us a document. We can read that document and can come with a more educated, hopefully, point of view after reading that document to the discussion in 2 weeks from now.
Yeah, we could do that. That's fine. The other thing that I would like to suggest is, this go ahead and start editing the document. Let's get out of the comments mode and let us get into the mode where, hey, if you think that there is a section missing or a section that needs to be updated, just go ahead and make the edits. That way, we can move faster in getting the content to the place where we all feel comfortable. Okay. So my request, don't stick with comments. Go in and start editing the document and changing your pieces. Turn tracking on so that it becomes easier to know what changes have been made.
Okay, thanks everyone. This was a really thorough discussion, and I'll take the action items of adding this again to the agenda for the TAC meeting in a couple weeks, and I'll make sure that that link is included, or Raghuram, if it's easier for you to just drop the link in the TAC Slack channel so folks can just jump right in and start making comments. But Kevin was able to join, so I'm going to hand off chairing the rest of the meeting to him.
All right. I'm going to drop off. So thanks very much for a good discussion. And
Yeah,
I appreciate you guys inviting me.
Yeah, no, thanks for joining. Thanks everyone for participating. This seemed like there's a lot of great feedback and ongoing conversation around this topic.
All right. Thanks, folks. Thanks, Michelle, for covering for the first hour. My apologies for missing out on that. Let's go back to the agenda here. So, so we had our discussion with the agentic AI paper. Unfortunately, it seems like Solomon is not here for the next discussion, so we'll have to table that for next time. And then it seems like it's the same case for like Alec and then Simon as well here. So let's see what else we have here. So I guess in terms of the works in progress, we have the agentic AI paper as we had just mentioned. Please provide your feedback, maybe add some edits to this as well. And then similarly for like the blueprints and the blueprints for what was discussed for Simon and Alec as well. Just make sure to just provide your comments there. The next thing we have here is, the next meeting is on September 3rd. I think Alec will be able to take on that. And so I think the major projects that we'll have are like, the D-Stack as well as we'll have I guess a discussion on D-Stack as well as the MITRE paper. Unfortunately, the MITRE folks weren't able to present this week, so we have to table that as for next week as well. I think that's everything for this week's agenda, since unfortunately it seems like a lot of people are still on vacation. I guess Michelle, do we have anything else that we should be discussing?
You can just open it up if anybody has additional topics. I'll add that I think we're almost at the point of publishing the Blueprint C paper. It's gone through final revisions. So we should be able to get that published this week. So some progress on that item. But otherwise, I think unless some folks have any other topics they want to bring up or address or ideas for
actually, just one
comment.
comment. This is John again. Mark and I guess Manu, who spoke before. The certifier adopts the same philosophy. No PKI dependence, no nothing. Keys are generated in the enclaves or in the certifier, depending on which key you're talking about. And that's that. Now, if you want to end up delegating trust to somebody else, that's your lookout. But
yeah, thanks, John. I think this is the crux of what confidential computing enables, is that for the first time in the history of computing, we have the ability to create, full entropy cryptographic secrets alongside general compute capabilities
I agree.
in a hardware enforced trust boundary
Right.
that is verifiable.
Yep.
And that is a new primitive that we just didn't have before. And
I agree.
it forces us to rethink, the fundamentals of what we do. And if the CCC embraced this philosophy to the fullest, then we could really just stand out and say, and of course, meeting people where they are, but at least we would know exactly where we delegate trust, as you said, or accept, unverifiable trusts when we interface with systems that are not verifiable. But I think that's really what the CCC should stand for, because we have a role to play, and if we don't play it, nobody will. So. And by the way, I think what we should probably also do is use the mailing list, the TAC mailing list, to continue this conversation, because we may reach a larger audience than the people who can actually attend the call, and it may help us move forward in between calls.
Yeah. So while I have your attention, and we've been talking about AI, I want to plug the GRC SIG. So we just finished the last big chunk of work. We updated the verifier governance pattern for trust anchor separation, which, by the way, may sound like a very niche and esoteric thing, but without it, you don't have a prayer of passing audits. Right. So again, this goes to success of technology is determined by the rate of its adoption. And we published the proxy and gateway governance pattern. So this is for all the web application firewalls and things that deal with your data, and how do you actually ensure end-to-end data protection, where you have to insert a trusted intermediary into things. So we now have that out, which means we're free, and we're going to resume work on governance for confidential inferencing and then confidential training. So here's your scenario. And the idea is you create guidance for adopters so they can deploy systems like this, know what questions to ask, know what controls to put in place, know how to convince their auditors, their customers, their partners that the right thing is actually happening, which again, this is the practical part of it. So confidential inferencing is the following. A bunch of banks would like to utilize a system that's hosted by Microsoft or Google, whatever, that collects data from all the banks and looks for money laundering. And there is a provider for this anti-money laundering software that knows how to look for all the tricks, that has its own IP that's encoded in the model and wants to get charge customers for service. And the banks are limited by regulators in who they can share their customer data with. And certainly they cannot share data directly with other banks, right? So you basically have the cloud service provider saying, I want to do nothing with knowing customer data, especially for regulated institutions. So I'd like to provide a service and charge for usage. There is a model provider that says, I would like to keep my model architecture, my model weights confidential, and get, again, charged for usage. And then there are all these contributors of customer data who want to make sure that their customer data doesn't leak, but yet, they can identify who is breaking the law. So we are working on guidance for how something like this can be implemented, and what evidence needs to be collected, and what control objectives there are, and basically mapping it all so that we can take this stuff to regulators and say, look, adopt these guidelines, and the world will be a better place. So join us every other Wednesday, and look up the CCC calendar. The invite is in there.
All right. Does anyone else have any other open discussion topics that they would like to talk about? All right, cool. Yeah, if that's the case, well, thank you folks for joining this this week's meeting. I think if there's nothing else, Michelle, I don't know, do we just wrap it up here? Do we wrap up earlier?
Yep, I think we can just wrap up early, give everyone an extra half hour back to their day.
All right, perfect. All right, thanks, folks.
Thank you, everyone. Take care.
Bye.